So before we talk about go into the discussion of temperature, particle size, and stirring, let's think about what happens when something dissolves. So I have, let's say, a solid in a solution, right? And let's say I have a chunk like this, a cube, and I have some solvent in here. And I'm going to do some dissolving of this solid. Where does the dissolving take place, right? Well, if you think about it, it takes place at the surface of the solid. So it can only happen there, and then inside, right? Inside the solid, dissolution doesn't take place. So it is protected from the solvent. Now, let's think about, too, what that means in terms of particle size, and we'll talk about the effect of temperature as well. So let's say you have a chunk, and let's say this is a 1 gram cube, okay? Like a sugar cube or something. And if you notice that when you take a sugar cube, if you've ever done it, it's actually loosely packed sugar. So the reason it dissolves so well is it has holes in it that allow the liquid to go into it. But let's just say this is a crystal of sugar. It would actually be hexagonal, but let's just assume this is a crystal of sugar. It has a certain amount of surface size on it. Let's say it's 1 gram. Well, if you break that into 2 smaller particles, or 4 particles, or 8 particles, right? This is the surface area, right? And this is my mass. It turns out as you go to smaller particle sizes for the same 1 gram mass, it'll have a greater surface area to mass ratio. This is the same reason, if you've had a biology class, the same reason why per pound a mouse consumes more food per pound than an elephant does, because remember, mammals are warm-blooded, and the mouse needs to generate heat basically to stay alive. And because he's so small, his surface area to mass ratio is huge compared to that of an elephant. The elephant can't lose heat from the inside of his body, he only loses it from the outside. So when solids dissolve, it's dependent on the surface area to mass ratio as to how much of the solid is exposed to the solution. So the result is, right, if you have smaller particle size, you increase, for the same amount of mass, you increase the rate of dissolution. So smaller is faster. Now, why does temperature matter? Temperature matters because dissolving requires that particles be broken away from the surface of the solid, and the temperature provides kinetic energy for that to happen. So temperature increases, right? Increasing T equals increasing kinetic energy, and that increases the rate of dissolution. So higher temperatures are faster. And on an everyday sort of practical nature, like when you're trying to dissolve sugar in water, right, to maybe make candy, or like I commonly make a lot of teriyaki sauce. I know it's a little bit of a stereotype, but I make a lot of teriyaki sauce. And when I do that, I always heat the soy sauce first, and then I add the sugar to it. And because I know that heating it allows it to dissolve faster, and then I don't burn the sugar on the bottom of the container that I'm heating it in. If I put the sugar in and then start heating the sugar with the soy sauce on top of it, and I don't stir it, we'll talk about that, then what happens is I can sometimes burn the sugar onto the bottom of the container. So how does stirring increase the rate of dissolution. And let me draw sort of an expanded view of what's going on the surface here. So we're just looking at this side. This is my solid over here. And the solid is dissolving off into solution over here. And let's assume there isn't any stirring initially. So this is the container like that. Well, what ends up happening is you form layers of concentration along the side here, and this becomes saturated. Now, it'll also be more dense. So actually, if you do this with like something solid, like a big piece of rock candy, you stick it in solution, the solution becomes more dense. You can actually see the difference in density as it flows off of the solid. Okay, so having said that it's saturated, what do we know about solids in a saturated solution? We know that they stop dissolving. They sort of reach that dynamic equilibrium. And this can be true even though on the outside of the saturated layer I have water, right, or solution that is unsaturated. So the way stirring helps to make the dissolving process faster is it brings solvent to the saturated solution and then pulls it away and dissolves it and makes it unsaturated so that more solid can dissolve. So the rate of dissolution can be increased simply by stirring the solution, having a higher temperature. These are all kinds of things you know, like from making a cup of tea or something, right? And by having smaller particle size. So that real fancy sugar that you buy that has big chunks in it is harder to dissolve than the sort of the cheaper CNH or whatever you buy, Costco brands things, right? Those particle sizes are smaller, and then those allow them to dissolve more quickly in solution.